Welcome to Automated Visual Software Analytics. This part is about static source code analysis. We will have a look at the specific characteristics of source code with respect to source code analysis. We will also define and see how source code analysis works. And finally, we will have a look at some tools in that area. Source code. Source code most likely is the key artifact all developers are involved in. Source code is a formal and complete description of any program that is automatically translated or interpreted by programs or machines such as compilers and interpreters. Source code is written by human developers, mostly. Sometimes we also have source code that is generated automatically by corresponding tools or maybe derived from models. Regardless where source code comes from, a key question is how can we evaluate source code? In the picture you see here, there's one technique applied called source code highlighting. This is, in a way, an extreme example of using colors to highlight source code, and it's up to you to evaluate whether this is useful or not. But the general technique, highlighting source code, represents a first step, an old step, to get better understanding about source code just by printing source code in a different way. For example, variables, when introduced, are set in a bold font. All variables get a unique color. Terms from the programming language, predefined tokens are written in black. This may help, and it generally does, to understand source code more efficiently, because it helps the human eye to differentiate different parts of a source code and to emphasize different semantics of the written texts here. Source code is also related to corresponding management tools such as version control systems. They are also called revision control systems or repositories. They allow especially large teams to collaborate on the implementation of complex software systems. They represent a central base where source code is stored and where source code variants are held. They record any changes made to a system's implementation by any individual team member. A central repository manages file updates, records annotations for any changes, and offers services to merge different branches of a system or subsystem contained in the repository. Examples, and most of you will use one of them or even more, include the concurrent version system CVS or the Apache Subversion system, in a way is a successor of CVS, or Git distributed version control system. Basically, all repository systems provide a rich set of functions that help to manage source code. But they are in the background. They are just managing how software is modified and how changes are checked in and how parts of the system are checked out. They do not provide any analysis functionality, but we have to keep in mind that these systems help us to organize the work on source code. The static source code analysis aims at verifications that ensure coding quality and reliability of the source code. For that reason, they analyze the source code or sometimes also the binary code of an implementation without running the system or considering specific inputs given to the system. So it's called static because we do not consider real-time behavior or system dynamics. This is up to dynamic coding analysis techniques. Static code analysis, of course, cannot check everything, but it can check a significant part that contributes to the efficient management and efficient development of source code and software projects in general. Especially static code analysis can check if reasonable, recommended or common programming practices are violated or respected. In a sense, it represents a white box testing method, considering the implementation, ignoring the functionality, because the functionality cannot be considered as the system is not, is not executed. Static code analysis takes place at a very deep level every time you compile, for example, your system. The compiler, in a sense, is the most prominent static code analysis tool. There are, of course, more sophisticated tools around that complement the functionality compilers provide. To give you just one example, here's a CLang compiler is invoked and syntax only is checked for a given file, t.c, and in that file we have encoded an error, an obvious error. Here it's applying the plus operand operator to two operands, and one of them, later one, is not compatible to this operators, and of course the compiler reports a corresponding error. Sometimes compilers report warnings and we all ignore them. However, what compilers can report, if activated, is sometimes worth to be considered in special phases of a project, because compilers are very strict and can detect a lot of weaknesses in programs. Goals of static source code analysis. Yeah, what are the goals? Basically, we want to find and identify a number of weaknesses. These weaknesses include, for example, unused or unreachable code segments, uncommon usages of the programming language, error-prone statements, or bug-suspect code segments. Bug-suspect means, for example, if a variable is not initialized, it is likely that this can cause an error in many situations. So uninitialized variables are considered to be error-prone. Unused functions or method, interesting question, why is this function never used? Why it's in there in the source code? Assignments in conditions, a bad programming practice. Fall through in case statements is another example of such weaknesses we can detect by static source code analysis. Source code analysis can also be used to find out whether a given implementation follows coding guidelines or formatting rules set up in a company or set up in a specific project. What else can be detected? For example, non-portable language usage can also be an issue if you plan to have a cross-platform compatible implementation. Though there are many things you can detect with static source code analysis. On the left side, you see a simple, small C program that contains some weaknesses. Those of you who are familiar with C will easily identify these weaknesses. For example, the variable C is not initialized. The if condition does not evaluate to Boolean, and moreover it contains an assignment, etc. The switch statement has a fall through or is missing a fall through statement. If we apply, for example, the Splint tool, a static source code analysis tool, and there are many tools around that offers this kind of analysis. If we apply this tool to this source code, The tool reports the following recommendations and messages. It tells us variable C is used before definition, there's a suspected infinite loop, or there's an assignment of integer to a character variable. There's also a test expression that contains an assignment, which is unusual. And finally, the fall-through case is not implemented. If we take into account these warnings, we can rewrite the code, and this is how a possibly less error-prone implementation would look like. Now we have added the initial value of the variable C, we have a correct if condition, and we have the fall-through case added. This shows how warnings can be used of static source code analysis tools to improve source code quality. To give you one more example where to start, you can most easily start with your compiler. Have a look at the options compilers typically offer. For example, in this case, a GNU C++ compiler. They offer, in general, a number of flags that allow to set up, to activate static source code analysis techniques. For example, in this case, we can ask and force the compiler to check for certain standardizations of C++. We can activate a number of warnings, for example, detect unused parameters, detect when classes have private constructors and destructors, warn us if a class has a non-virtual destructor, and so forth. For example, all warnings are listed here. It's still not complete. You can easily find out the complete list of warnings in the manual of your compiler. Take into account that these warnings are typically not activated, so make sure to activate them if you want to apply a first version of static analysis to your source code. In the same way, compilers and even interpreters can give you this kind of warning in the sense of a static source code analysis. It's a valuable tool, and it's already out there, so make sure that you actually take advantage of these features compilers and integrated development environments offer us. Yeah, static source code analysis also has some flaws, some weaknesses. Sometimes too many useless, spurious warnings and errors are reported. And from a psychological point of view, this causes that developers start to ignore the outputs and results. It leads to developer confusion due to a large number of false positives. Sometimes tools take too long to check the source code basis, and therefore their application is skipped. Yeah, these are basically the key weaknesses we find in source code analysis. It's also strong for all compiler-based languages, but of course it's less applicable to dynamic languages such as Ruby or Python or Perl. It's much more difficult to find reasonably deep checking levels there because there's no compilation behind, which is a check for formal and syntactic correctness. Yeah, one more an overview here about tools. We have different language-dependent tools, for example, for the C++ language family, Splint, C++ Lint, C++ Check, Coverity. All these are examples of tools, and if you look around, you find nowadays a number of services, even software as a service tools that allow you to scan your source code and to find out, hopefully, good reports about the weaknesses contained in your current implementations. There are also some Java tools around like FindBugs, CheckStyle, or PMD. Let's summarize this part. Static source code analysis is an effective way of improving software quality and reliability, in particular if applied regularly and if complemented by project or company-specific coding conventions and programming guidelines. Source code analysis analyzes and evaluates the use of language elements and identifies potentially dangerous codings. That's their core business. This is what source code analysis can deliver to you. Software analytics uses static source code analysis to a large degree as a key data source to analyze, evaluate, and visualize the as-is status of a software system. It provides base measures and metrics information about the implementation. So in software analytics, we take advantage of all these tools to gather this kind of information in order to do more deep analysis in a next stage. This is up to other parts of this course when we will have a look at how complex information about the as-is status of a software system is actually visualized and analyzed. Static source code analysis contributes to the information used by software analytics. So it's one of the big bases where we take information about software systems. Yeah, this concludes this part. Some terminology we have learned about source code, computer instructions and data definitions expressed in a form suitable for input to an assembler, compiler, or other translator. Statement sometimes is used in a programming language, a meaningful expression that defines data, specifies program actions, or directs the assembler or compiler. Statements typically are the level where static source code analysis takes place. Object code, some tools are around that even analyze the resulting object code after compilation. And finally, static analysis, a process of evaluating a system or component based on its form, structure, content, or documentation. As a further reading, I can recommend this article about using static analysis to find bugs from 2008. Have a look at this. It reports on how FindBugs, this tool, works, a Java static source code analysis tool. Some remarks. Syntax highlighting, context-sensitive code editors and integrated development environments in general already provide a number of static code analysis functionality by now. Make sure to turn them on, to be aware of this kind of functionality, and actually to read, to use, to discuss the results of this functionality. Today's C and C++ compilers perform a broad range of static source code analysis as built-in functionality. Look at the exact list of options and configuration flags of your compiler. For example, in certain intervals, a software project could be compiled and built with a strict compiler flag setting. See especially your compiler option list in the manual of your compiler. Make sure that you use these warning functionalities, the static source code functionality, at least at some time intervals during your project development.